Number 64 says, give the number of valence electrons in each element and write out the electron configuration for the valence electrons. So maybe the easiest thing is to just write the electron configuration, and then you can spot the valence electrons. So we'll start with neon. So there is neon right here. Let's break out the other periodic table. Here it is right there. So this one kind of helps you write so there's neon right there. This one helps you write the electron configuration. Now, if you want, you can just skip everything except for, you can write it out, the full thing if you want. So 1s2, and then 2s2, 2p6. Okay, 2s2, and then 2p, 1, 2, 3, 4, 5, 6. So there's neon. And of course, the first part, the valence electrons are these second energy level electrons. So there they are. And you can see that you have 2 plus 6 is 8 valence electrons. So 8 valence electrons. And then the electron configuration for the valence electrons, we can just copy this over. There it is. Okay, B. Which one was it? Where is B at? So B is rubidium. Okay, rubidium is over, let's see. Here it is, right there. Element number 37. Okay, the fifth one down in the first group. Fifth one down in the first group. There it is, right there. So you can you can write it all out, or the easiest way is to go to the previous noble gas. Okay, the previous noble gas. So here was rubidium right there. The previous noble gas is at the end of the fourth period. And so going back to, there it is, that was krypton. Krypton, so we'll just write, so this is for rubidium. And so krypton. And then continuing on, 5s1. That's pretty easy, isn't it? 5s1. And you can see from the electron configuration, everything inside of krypton, that 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, all of those electrons, okay, are in lower energy levels than this one. So you don't even have to worry about that part of it. Okay, this is the highest energy level electron. You can see there's only one electron in the fifth energy level. So we say there's one valence electron. So one valence electron, and the electron configuration of the valence electrons is simply that. So C is aluminum. Oh, by the way, I'd like to point something out. So let's go back to the other periodic table. When you have rubidium, okay, look at the group number. The group number is 1A. Okay, don't look at that type of number. Look at the A's. If you have one of these main group elements, like in these two columns or in those two columns, the 1A tells you that means there's one valence electron. All these guys have one valence electrons. 2a, all of these guys have two valence electrons. It doesn't work for this transition element section, but whoops. Where did it go? It doesn't work for the transition elements, but it works for the main group, these two columns and then those 6 columns. So we did neon. Neon had 8 valence electrons, and look, this is group 8a. Okay? So if you have one of the elements inside this part or inside that part, if you just want the number of valence electrons, just read it off of the group number, 1a, 2a, 3a, 3 valence electrons for these guys. All right, so let's go back. The next one was aluminum. I think that's a main group element too. So aluminum. And if we go to the periodic table, find aluminum. There it is right there. You can see it's in group 3A. So I'm just going to bravely put 3 valence electrons. We can check that if you want with the electron configuration. So aluminum was right there. It was right below boron, right? So there it is, right below boron. And so 1s2, 2s2, 2p6, 3s2, 3p1. So that's 1s2, 2s2, 2p6, 3s2, 3p1. And you can see those electrons in the third energy level. You got two here and then 1 there, so 2 plus 1 is 3. And the electron configuration of those valence electrons is, just copy that down. There it is. Now, you couldn't see that part. So there it is. Just make sure that you see what I did. So to get to aluminum was right there. Just walk back through it for a second. 1s2, 2s2, 2p6, 3s2, 3p1. And you can see these are the valence electrons. You have 2 plus 1, that's 3 of them, so that it worked. And then this is the electron configuration of the valence electrons. So it works. Now, the next one is manganese. So manganese is in here somewhere. So you can't read the number of valence electrons off of the group number for these guys. So manganese, there it is, right there. It's the 5th one right there. Okay, the 5th one right there. So to get to the electron configuration, let's use the noble gas. So that one is argon. Okay, so you start from argon. Okay, let me make a little room. So this is for manganese. You start from argon, and then you continue on in manganese's row. Okay, 4s2, 3d5. 4s2, 3d5. Okay, now what are the valence electrons? Okay, the valence electrons are the highest energy level electrons, and these are in energy level 4. So you can see there's only 2 of them. 2 valence electrons for manganese. These are not valence electrons. Okay, these are in energy level 3. So it's the highest energy level, which are the valence electrons. So sometimes the valence electrons come before the end of the electron configuration, like in this case. And so we could really just copy that part down and paste that. There we go. So I'll do one more. I'll do the last one. E. Zirconium. Zirconium is also a transition element. It's right here. Right here. So the second one in the D block in the transition elements. Okay, the second row and the second one. Okay, so it's right there. It's right, that one right there. So you can end in 4D2. So we'll start from xenon and then 5s2, 4D2. So xenon and then 5s2, 4D2. And again, you got these two valence electrons. And the electron configuration of those are 5s2. So, see that? 5s2. Now I'll give you a little heads up. All of these elements in the D block have two valence electrons. Okay, two valence electrons. No one really cares about the valence electrons of these guys. We only care about valence electrons for those guys and those guys. But you were asked, and that's how to do it.